For number 3, we're trying to figure out the regions where it's increasing, decreasing, as well as the local max and mins. And we're using the derivative to do this. So before I actually take the derivative, I'm going to write this in a different way so that I don't have to use the product rule. So this is actually equal to 2x to the 2/3 minus x to the 5/3. So if you distribute that x to the 2/3, this is what you should get. So then when I take the derivative, f prime of x is going to be equal to, this will be 4/3 if you multiply 2/3 by 2, x to the negative 1/3. So if you subtract 1 from 2/3, you get negative 1/3, minus 5/3 x to the 2/3. So this is my derivative. I do want to combine these two terms under one term. So I'm going to write it a little bit differently. This is going to be 4 over 3x to the 1/3 minus 5x to the 2/3 over 3. So I do need to get a common denominator here. So I can do that if I just multiply the second one by x to the 1/3. So that will be able to get me the same denominator. So if I combine those, that's going to be 4 minus 5x, because x to the 1/3 times x to the 2/3 is just x. And this is over 3x to the 1/3. So that would be my derivative. We want to set this equal to 0 to find our critical numbers. So if we take 4 minus 5x and 3x to the 1/3, and I'm setting it equal to 0. If you look at the top, 4 minus 5x is equal to 0. Then x is equal to 4/5. And if we look at the bottom, then it's going to be 3x to the 1/3 is equal to 0. So here x is going to be equal to 0. Now this is undefined in the derivative, which that's okay. It can be undefined in the derivative, and that will be a critical number. It's only when it's undefined in the original that you'd have to throw it out, and then it wouldn't be a critical number. But 0 is actually okay in the original. So these are your critical numbers. So I'm going to take those and I'm going to put them on a number line. So 0 and 4/5. If you plug 0 and 4/5 back into the derivative, you should get 0 and undefined. You want to plug in numbers now that are in between these numbers, so within these regions. So if you plug in like -3, then you should get a negative number. If you plug in a number between 0 and 4/5, like 2/5, you should get a positive number. And if you plug in a number greater than 4/5, like 3, then you should get a negative number. Again, you can do this by using the table, or you can just plug them in manually. So the regions where it's increasing would be from 0 to 4/5. Where it's decreasing, this would be from negative infinity to 0. And then from 4/5 to infinity. Your local max, this is going to be at the 4/5, because that's where it changes from positive to negative. And the local min is going to be at 0, because that's where it changes from negative to positive. Then to get the y values of these, you want to plug them into the original. So if you plug in 4/5, you should get 1.0341, and if you plug in 0, you should get 0. So that'll be your answer.